Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. You know, for the last couple of weeks, I've been infiltrating the Flat Earth community with the idea of using them to destroy their own Flat Earth fantasy world. And I was successful beyond my wildest dreams. Today is the day that minstrels will sing songs about for generations to come. It is the end of the silliness known as the Flat Earth. And I'm going to do it with my father's slide rule, and the help of Nathan Oakley, Quantum Eraser, Brian's Logic, Mitchell from Australia, and Planarwalk. So let's cue up the music and let the fun begin. Now, other than a good laugh, the thing that we can always count on when we deal with the Flat Earth is that they will respond to every challenge with aggressive stupidity. And because they are aggressively stupid, they never felt the need to actually learn the model. That's to their detriment, because then what happens is they fall into traps that we lay for them. And Quantum Eraser is no exception to that. Now, this is something that I did to Nathan Oakley and Brian's Logic. And Quantum Eraser, and I believe this is the 10th man, really summed it up nicely. Now, Nathan was a little cleverer than you would expect him to be. He kind of resisted the trap, but eventually fell for it. Quantum Eraser and company just drove right into the kill zone and said, "Here, ambush me." Well, John, I'm happy to do that. Thank you for your help. So let's go ahead and have a listen to John, and I believe it's the 10th man.
Could it be that Stick Bob and the rest of the Baltards are? Could it be? I wonder.
I have a degree here. I have a location here. And I'm not going to get into the math because that's not the purpose of this video. But essentially, what you're able to do, what the book is able to do, is to say, listen, if you're seeing star A at 50 degrees, okay, and not at 90 degrees, well, the only way you can do that is that you have to be a certain distance away from its location at 6 p.m. Okay, and it's basically going to build us a little circle here. So let's just make a number up. Let's say in order to see star A at 50 degrees, okay, at 6 p.m. at night, you have to be 900 miles away to be able to see that observation. Okay.
What, really? Why would you have to make a number up? That's my question. So some comments, just brief comments. Does he have to make a number up here, or can you get a distance here with just the information you have? Anyone?
Yeah, he can get a distance. If it's 50 degrees and you take it from 90, it's 40. So 40 times 60 nautical miles would be 2,400 miles.
I must have did it. Yeah, I got 2760. I could have did. I just jotted it. Go ahead.
I'm doing nautical miles, not.
Oh yeah. See, that's the damn yeah. Ugh. Yeah, forgot to convert them over. But yeah, you could do that. I just wanted to stop right here. It's arbitrary, I know. Don't worry. He said, let's just put 900 miles here. You get the concept in what he's trying to tell you.
Well, you bring up a good point. Because he just was trying to hurry up the video. So he just said, let's just make a number. But all he had to do was minus 50 from 90. That's 40. 40 yep. Times 60 is 2,400 miles.
Yeah, I went 69 miles. You used nautical miles. You friggin' squid. Yeah.
And right there, John, is the destruction of the Flat Earth. And you didn't even know that you did it. Let's go see what you actually did. And by the way, your little minions, your little groupies in your echo chamber there, continue to agree with your wonderful assessment and your great math skills with this. But the bottom line is this. You have demonstrated one of the principal concepts of celestial navigation. The way you find the distance to a geographic point on the Earth is you take the number of degrees you are away from that distance and multiply it by 60 nautical miles, 69 statute, or 111 kilometers, in any direction. And you just confirmed it, my friend. Let's go see how that destroys the entire flat Earth. You know, one of the key tenets of the flat Earth fantasy is that they refuse to adopt a model, or at least they claim they don't have a model. Well, first of all, they do have a model. They have a model that the Earth is a flat plane. That's a model. That's measurable. That's testable. But more importantly, what Quantum Eraser and Company just did was they gave us all we needed to test and invalidate their model. Let me show you what we're talking about. This is the United Kingdom. Nathan, are you listening? As you can see, that's London on the right, and on the left is Bristol. And I have drawn a line along 51.5 degrees north latitude, which roughly connects the two cities. That is a measurable line over the surface of the Earth. And as you can see right here, there's actually a road that pretty much goes right along it. So Nathan, you can take your little car out, drive on the left side of the road, and look at your little odometer, and you can measure that distance if you don't believe Google Maps. But let's go ahead and see what happens when we do look at that distance. Now, are you boys paying attention? Here's the coordinates for Bristol in the UK. There are the coordinates for London in the United Kingdom. The distance between them is 92.36 nautical miles, and that is 2.462 degrees of longitude. Using that, we can calculate the length of the entire 51.5 degree line of latitude. And that comes up to 13,510 nautical miles to 4 significant digits. That means it has a radius of 2147. Now here's the problem that you run into, and this is the downfall of the flat Earth. How far is 51.5 degrees from the North Pole? It's 38.5 degrees. And that works out to 2310 nautical miles. Ruh-roh. Now here's your problem, guys. And this is the first nail in the coffin of the flat Earth. The circle, based on the distance from the North Pole, would have a diameter of 4620. You have to fit that in to a circle that has a diameter of 4294. That's smaller than that. So what you have to do is you have to take your circle and you have to squish it. Oh, wait a minute. What happened there? Nathan? Quantum? What shape is that? Is that a curve? But that way it works for the distance from the North Pole, and it also works for the distance of the chord line. That's the chord line. That's the distance from the North Pole. But maybe this is an anomaly. Let's look at another part of the world. Hey, John, this one's for you. How about Pittsburgh, Pennsylvania to Philadelphia, Pennsylvania? All right. Pittsburgh, 40.44 degrees north, 80.01 degrees west. Philadelphia, Pennsylvania, 39.93 degrees north, 75.14 degrees west. Difference between the two, 4.87 degrees. Now there's a very slight difference in the latitude, but I think you'll agree that half a degree isn't going to make that much of a difference. So let's take 40 degrees north latitude. Well, the length of that entire latitude around the North Pole would be 16,672 nautical miles. That gives it a radius of 2653. Now, if you look at the distance to the North Pole, that's 50 degrees times 60 gives you a radius of 3,000 miles. So John, how are you going to squeeze 6,000 miles into 5,308 miles. You'd have to kind of do, oh, wait a minute. There's that shape again, John. What's that called? As a matter of fact, it's a little bit more than the one we had for Nathan up in England. But this is fun. Let's go ahead and do it again. How about, boys and girls, we go from the North Pole down to the equator. That's 90 degrees times 60 nautical miles. Right, John? It's 60 nautical miles, isn't it? 69 statute miles. That was your mistake. You didn't do the conversion because only squibs use nautical miles. Well, what would that equal? Well, it would be 5,400 nautical miles from the pole down to any point on the equator. Double that, multiply it by pi, and you have the circumference of the circle. 33,929 nautical miles. That's the flat Earth length of the equator. How long is the measured length of the equator? Wait for it. John, do you remember this? Nathan? So you've got to fit a circle that has a circumference of that into a circle that has a circumference of that. That means you got to go like that. What's that shape again, guys? Is it a curve? Mitchell, this one's for you. How about Perth in Western Australia? The Forester, which I guess is north of Sydney, so that would be what, New South Wales? Here's the coordinates of Perth and Forester. It's 36.37 degrees of longitude between these two locations. And again, we're actually in the other hemisphere. We're in the eastern hemisphere now. And that distance is measured out at 1,859 nautical miles. Now that would give a circumference of the Earth of 18,400 nautical. Wait a minute, that's less than the equator. I thought it would have to be more than the equator. We'll figure that out in a minute. And that would be a radius of just shy of 3,000 miles. So Mitchell, help me with the math here. How far is 32 degrees south latitude from the North Pole? That would be 90 plus 32, or 122 degrees. Multiply that by 60 nautical miles. Well, let's see, that would be 7,320 nautical miles. I wonder how big a circle is that has a radius of 7,320 nautical miles. Let's find out. If that's the radius, the circumference of the Earth at that point would be 45,992 nautical miles. But that's okay. I've got my visual here for you, Mitchell. So, at the equator, we had to bend it like this. But now we have to go even smaller. I think we have to bend it something like that. That's starting to look awful circular, isn't it, Mitchell? You agree that looks circular, right, gentlemen? Nathan? Quantum eraser? That's starting to approach a circle? What do you think? Can you see it okay? Can you see that, guys? Here, let me draw it for you. Okay, gents, let's see if we can put this into some perspective. So, here's the North Pole, right here. Now, Nathan, you're at about 51 degrees north latitude, and that would make your degree of latitude about there. Now, here's the distance from the pole that you have to cover. And here is the distance that you have to cover it. You with me so far? That's a curve, Chief. Hey, quantum eraser, let's do you next. So here is about 40 degrees based on the distance between Pittsburgh and Philadelphia. We know that that's how much distance you have to pack that much distance between the pole and Philadelphia. What shape is that, John? Does that look curved to you? Next, let's do the equator. Well, there's the equator. And we've got that much space to fit that much land. Because remember, that's 5,400 miles to the equator. And this is only 21.6. Now, last but not least, Mitchell. Here is 32 degrees south latitude. We can't see where you are right now because you're literally on the other side of the spherical Earth from John and Nathan. But that's okay. We'll roll with it, man. So here's 32 degrees south, and you have to fit all of this back up to the North Pole in that little segment. So, man, you really got to get bent. And quite frankly, your diameter here is less than that diameter. It's not looking really good for the flat Earth right now. That looks pretty spherical to me. But since you guys will never bother measuring any of this stuff and you'll all say it's a fake construct based on mathematics, not a problem. Let's go do a real life measurement of it. And for that, we need to go to New Zealand. Now, one of the problems that you run into when you try and test the flat Earth is they always say, well, look at that airplane. How do we know where that is? We can't track it. Look, here are 12 flights that I found online that take me from Sydney, Australia to South Africa by way of Dubai. You know, of course, that looks over every direct flight, but they want to find one that stops in the Northern Hemisphere. Well, let's do it the old-fashioned way. Let's take a cruise ship. And what we're going to do is we're going to go from the Bay of Islands in New Zealand. And while we're there, we're going to say, hi, Planarwalk. That's the only reason I mentioned him, was to give him a shout out. He's a cool kid, so check out his videos and his channel listed in the description. Thanks for letting me borrow your country for this. Now, on the North Island of New Zealand, they have the Bay of Islands. And this ship leaves the Bay of Islands and sails directly west to Australia and docks in Sydney. Now, the distance here is 1,300 nautical miles. That's at least on the globe. Based on the fact that this averages about 34 degrees south latitude, 124 times 60 would give you the distance to the North Pole. Multiply that by 2 and pi, and you get the circumference of the Earth at that distance from the North Pole. It comes up to over 45,000 nautical miles. Divide that by 360. Multiply it by the 20 some odd degrees between Bay of Islands, New Zealand, and Sydney, and you find that this flat Earth journey is some 3,000 nautical miles. Well, here's where the problem lies. They leave the Bay of Islands on Friday, October 21st, 2022, and the sailing time is 4 p.m. Now, that would be 2 p.m. in Sydney. And notice, in 24 hours, they're at sea. At 48 hours, however, they do dock the next morning, and that is 62 hours after the time that they left. Well, let's do some quick math. Now, if the globe is right, the distance between those two locations will be 1,305 nautical miles. We'll divide that by 62. And we get a cruising speed on the ship of 21 knots, which is nautical miles per hour. Now, if the flat Earth is right, well, that would be 3,000 nautical miles in the same 62 hours, which means the cruise ship has to make 48.38 knots in order to make that journey. That's faster than a warship. But how fast do cruise ships go? Well, let's find out. Let's do a search for the fastest cruise ship in the world. And according to this, it's the Queen Mary II. Let's look right there. What's that say? So, can reach top speeds of up to 30 knots. That's a long ways from over 46. Well, gentlemen, I want to thank you all again. Specifically, Nathan Oakley, Quantum Eraser, Mitchell from Australia, The 10th Man, and Brian's Logic. Thank you again for allowing me to put the flat Earth to bed once and for all and demonstrate clearly that the Earth is a spherical planet. Welcome back to the globe reality. I couldn't have done it without you. So, this is Bob the Science Guy signing out from Northern Michigan, wishing you the best of luck on your next conspiracy now that this one's gone, and I'll see you again soon.